Hi, students. Good morning. Today we are going to discuss important questions which we are expecting in 2021. In part 1 of expected question, we finished 3 lessons, important questions we covered. And today we are going to cover uh, the lessons in wave optics, ray optics, alternating current, and electromagnetic induction. These are the chapters today we are covering. Maximum of some 20 questions we are going to discuss. Electromagnetic induction. So today we are going to do a lot of shortcuts and which you have to note it down. So it may be 1.5 hours time class. However, let us go for the first with the formula. What are the formulas involved in wave optics, ray optics? Important formula which we can expect this year 2021. Important formulas in wave optics and ray optics. Especially these two lessons first we are going to write. Then after that we are going to write with AC and electromagnetic induction. Please start, everyone start writing this particular formula which is very important. But today we are not going to use so many formulas, but however it's very important to note down the formulas in which you can do some of the sums by formula and some of the sums we are going to do by shortcut method. Now first formula, important formula we used to call as Snell's law. Please take your pen, take your notebook, and our academy students, please write down in your classwork Snell's law, refractive index mu is equal to sin I by sin R. This is the first formula in which we are going to memorize it. I is called angle of incidence and R is called angle of refraction. So today some 15 minutes will be spent for the formula. Don't think it is a waste of time. Formula is very important. So this is the first formula in which we are going to do it now. With the help of this particular formula we are going to do one sum today which has been asked in NEET 2018. So the first formula we written. If you want sin I, see from this we can project the formula like this. If you want sin I can write mu into sin R. And similarly, if you want I value, it is sin inverse mu into sin R. So please note down this particular formula again in which you are going to do it very shortly after finishing the formula. Finished. So let us go for the second formula. The second one is, it's a very important, same refractive index mu is also given by the formula mu is equal to sin A plus D by 2 divided by sin A by 2. So here A is called angle of the prism, and D is called the angle of minimum deviation. So second formula is also over. Let us go for the third formula. The same refractive index in a medium. We used to call this one as a refractive index of a medium is equal to wavelength in air medium divided by wavelength in a medium. This is also an important formula, note it down. The third one. There are so many formulas in this lesson, but the formulas in which I am expecting this 2021 as an 100%, only these formulas. So if you read these formulas is more than enough for this 2021. So first one is over, second is over, third one is also over. Let us go for the fourth one. Fourth one, it comes under YDAC. You know YDAC? It is Young's double slit experiment. I can just simply bet on this particular Young's double slit experiment. You will definitely have one question. 4 marks is assured. I am giving 100% guarantee. The weightage is more for wave optics and ray optics. That too especially with Young's double slit experiment. In Young's double slit experiment, the first formula you have to note it down is bandwidth. Bandwidth beta is equal to lambda capital D by small d. It's a very, very important formula. It's a so important formula. What is called lambda? Lambda is called wavelength. And capital D is called distance between the source and the screen. Distance between the source and the screen. Source and the screen. And small d is called distance between the two sources. Distance between the coherent sources. Coherent source. Do you know what is coherent source? If two sources have same wavelength, same frequency and same amplitude, remember this, if two light sources have same amplitude, same frequency, and when it goes in same phase, then we used to call the two sources is a coherent source. Remember this point. And Young's double slit experiment beta we have to find. So from this, through this particular formula, we can derive so many formulas. Like we can also find lambda, which is equal to beta small d by capital D. We can also find capital D. Capital D is beta small d by, yes, beta small d divided by lambda. See, we can find lambda capital D, and also we can find small d also from this, lambda capital D by beta. So remember, these are all the important formulas in which you have to remember. Bandwidth, to find the bandwidth, what are the parameters they will give? They will give wavelength, they will give capital D, they will give small d. If they give these three, it is very easy for us to find bandwidth in Young's double slit experiment. YDSC is called Young's double slit experiment. Don't forget. And also from this lambda we can find, we can also note it down this formula in your notebook. Please note it down, the formula in your notebook. The next one is capital D, the other formula, and finally with small d. And let us go for the next one. The next formula number, I think it is formula number 5. Formula number 5. Formula number 5 is also comes under YDSC. In YDSC, there are two types of fringes. One is a dark fringe, the other one is bright fringe. So to find the condition for bright fringe, let us write down the condition for bright fringe in YDSC, that is Young's double slit experiment, is x small d by capital D is equal to n lambda. This point is very important. If you want to find the value of lambda, I can write xd divided by n into d. You know what is d? So d is the distance between the two coherent sources. What is capital D? Distance between the source and the screen. X is called central fringe width. Central fringe width. So n is called number of fringes. Number of fringes. So this is the first formula for bright fringe. So let us go for formula number 6. In YDSC experiment, the condition for dark fringe. The condition for dark fringe, xt by capital D is equal to 2n minus 1 into lambda by 2. If you want to find the value of lambda, I can write 2xd divided by 2n minus 1 into lambda. Sorry. n minus 1 into capital D. You put it in a box. We are going to do some sums based on this formula today. And finally, we are rushing the formulas fast now. You know very well that is lens maker's formula. Lens maker's formula. Lens maker's formula is 1 by f is equal to mu minus 1 into 1 by R1 minus 1 by R2. R1 is called radius of curvature of the first lens and R2 is called radius of curvature of the second lens. Let us go for formula number 8. 1 by F is equal to 1 by V minus 1 by U is called, you know very well, it is Lenz's formula. V is called image distance and U is called object distance. So let us write it out. Number 9, ninth formula, 1 by F is equal to 1 by V plus 1 by U is called the mirror formula. Then finally, the expected formula number 10 for 2021. So, Brewster's law. Mu is equal to tan IP is the formula. Remember, what is IP? IP is called angle of polarization. Eleventh one, new fringe width. Beta dash is equal to beta by mu. Mu is called refractive index and beta is called bandwidth, you know very well. If you divide the bandwidth and refractive index, we will get the new fringe width. Remember this. Let us go for the next one, formula number 12. First minima of the diffraction pattern, very important formula. First minima on the diffraction pattern. Diffraction pattern. So very, very important formula. That is, the formula is that is equal to lambda capital D by A. D is called distance, A is called width, lambda is called wavelength. So I have just given 12 formulas only in this lesson. There are so many formulas apart from this, but I am giving you 100% guarantee that within these 12 formulas you can expect a 2021 questions from this lesson will appear. So I kindly request all of my students to write this important formula based on wave optics and ray optics. Now we are jumping onto the questions in this lesson. Now we are going to do a lot of shortcuts in this method, in this particular lesson. So we'll go for the first question in ray optics and wave optics with the help of a shortcut trick. So let me write on the question first. So please write on the question in your textbook, in your notebook. So it will be useful for you ever. So this shortcut tricks you cannot see anywhere in any channel. So that's why you take it granted. Write down this first question which is useful for your shortcut. Write down this. Young's double slit experiment. I have told you very clearly, in Young's double slit experiment, definitely one question will come in NEET 2021. This video is going to get recorded also. You can match the question with the present 2021 NEET question. So take down this important question in Young's double slit experiment. It takes time to write the question. However, it's very important to note it down. Especially our academic students, you can note it down in your classbook. Is first performed in air and then in a medium other than air. It is found that eighth bright fringe in the medium lies where fifth dark fringe lies in air. The refractive index is nearly equal to option A 1.59, option B 1.69, option C 1.78 and option D is 1.25. This question already has been asked in 2017. So don't think that the question which has been asked in the previous year will never come for the present or the future year. It is wrong. You may get the same type of question but not the same number. So this question I am expecting this year, not the same number, a different number. So I am not going to use any formula for this. So I am going with the just shortcut method. If you want to go with the formula method for this sum, I will tell you which are the formulas you have to use. You have to use the formula for mu m. It is lambda air by lambda m. This formula you are going to use. And also you are going to use this formula xd by d is equal to 2n minus 1 into lambda by 2. These two formulas you have to use if you want to go with the formula method. So these two formulas remember for the same NEET 2017 question in which it is there. So now what you have to do is just to see the two important numbers in this question. So I will just point out the question number 8th bright fringe, okay. Then 5th dark fringe. The refractive index. Use my shortcut formula now to go with the sum. So remember, so we have to find the mu m. That is the question. To find the mu m, what is there? How many bright fringes are there? I am writing the shortcut formula now for you. Bright, use my shortcut formula to find the refractive index. Bright fringe into 2 divided by n minus 1. Use this formula. Use this formula, you will get the answer immediately. What is the bright fringe value? It is 8 into 2. N represent the dark fringe. The number of dark fringe is 5. So 8 into 2 is 16. Then what will be the next value? 2 into 5 is 10 divided by 2. Be in the line. Just I will rub out this, keep it this one. I'll just write down the given values. It is always better, even though we are going for a shortcut method, it is always better to use the values. So I'll write down the values. Bright fringe. I'll write down the values here. Bright fringe is how much? So bright fringe is given as 8. Then, what is the dark fringe value? So dark fringe value is 10. Remember this. Now we have to find mu m. Correct? So bright fringe is how much? 8 into 2 divided by. So dark fringe is 5. Dark fringe is 5. So substitute here the value. So 2 into 5 minus 1. This is 2 into 8 is 16. 16, 2 into 5 is 10 by 9. You will get 1.78. So first write down the values of dark fringe and bright fringe and use my cheat code and shortcut formula. This formula is not there in any textbook. So this is a formula created by me in order to find the answer immediately with the help of a single formula. So please note down this formula and write down. So if I give some more sum, see where is the option lies? The option lies in option C. So just I will change the question for your practice. So take down some sum like this. So it is 12th dark fringe and 10th dark fringe. Do it after the session is over. So the options are, I can give one of the option as none of the above. Do this sum and if possible, please try to give the answer in the chat box. So let us go for sum number 2. Question number 2, the same shortcut method. It's a very, very important sum. So let us go for the second one. Now, the interference pattern, it's a very important sum. The interference pattern is obtained with two coherent light source, of intensity ratio 4. In the interference pattern, the ratio of I max minus I minimum divided by I max plus I minimum will be dash. This is the question. You know, there will be four options A, B, C, D. Let us forget the option for this. Let us go with the straight formula. See, the number intensity ratio is very clearly given as what? Intensity ratio has been given as 4. We can find the answer immediately with the help of my formula. So use the shortcut formula now. So what is the question asked? The I max by I minimum. Use the formula for this I max minus I minimum divided by I max minus I minimum. The formula is, it is 2 root n divided by n plus 1. Use this formula for all the sums. No need to worry about anything. So what is the value of n here? The value of n is called intensity ratio. It has been given as 4. That is 2 into root 4 divided by 4 plus 1. So what will be your answer? It is 2 into 2 by 5. So your answer will be 4 by 5. So I max minus I minimum divided by I max plus I minimum. It is not minus. I max I minimum divided by I max plus I minimum. What is the formula? What is the shortcut formula? Shortcut formula is 2 root n divided by n plus 1. The value of n has been given. Just substitute, you will get the answer immediately. So let us go for formula question number 3, which we are going to do in shortcut method. So we are going to do in Young's double slit experiment question, which is very, 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 very important. I hope everybody is clearly hearing my voice. So now let us go for the question number 3 today. Two slits in YDSC experiment. See, I am just taking more, I am just giving so importance for YDSC experiment. Have widths in the ratio 1:25. Very, very important model. It's a very, very, very important model. It's a very, very important model. Remember, the ratio of intensity, at the maxima and minima in the interference pattern I max by I minimum is equal to dash. Option A has given as answer 49 by 121, B 4 by 9, C 9 by 4, D 121 by 49. So now we are going to use only shortcut method. We can also do this same sum by the formula method. If you want to go with the formula method, you can use the formula method. That also I will tell you. So if you want I max by I minimum, you can use the formula called A1 plus A2 the whole square by A1 minus A2 the whole square. This is one of the formula. So the other one is I is directly proportional to A1 square, I1, and I2 is directly proportional to A2 square. With the help of this concept and formula, you can do this sum, but we are not going to do any formula. So I am just going with shortcut method. Use this shortcut method for all the sums. You will get the answer immediately. You will get the answer immediately. So what is the ratio is given? 1 by 25. See the shortcut method. See, to find I max by I minimum, what you do is take a root, put a side work. So there are two numbers, 1 and 5. You got it? You have to go with 1 and 5. So now what you are going to do is 1 and 25. First you take the square root for 1 by 25. If you take the square root for 1 by 25, what will be your value? Can anybody tell me what will be your value? Yes, exactly. It is 1 by 5. It is 1 by 5 you will get. Please note it down in your notebook. It is 1 by 5, first step. So you will get 1 by 5. If you take the root, you will get 1 by 5. Okay? Then, after that, what you are going to do is, you just add these two numbers. If you are going to add these two numbers, what you get? If you are going to get add is, we get 36. That is 6 we get. You square that number here. 6 square. Similarly, you subtract these two values. That is, we get 4. You put 4 square here. You got the first point? First you have to take the square root, we get 1 by 5. Then after that we have to add these 2, we get 6. And we have to subtract these 2, we will get 4. 6 square is how much? You know very well. 6 square is 36 by 16. Then you can stack it up by 4 tables. 9 times, 4 times. Correct? So we get root of 36 by 16. Correct? So then what will be the answer? So there is root of 9 by 4 will be our answer. And one thing don't use this square root. Cut this square root. I am extremely sorry. Now use this particular one, 9 by 4. So we get the answer lies in option C. Answer lies in option C. So what is the first method? Again I will repeat. So 1 is to 25 has been given. You have to divide it 1 by 25. Take the root. We get 1 by 5. Then to find the I max by I minimum, add these two and make square. 5 plus 1 is equal to 6 square. 5 minus 1 is equal to 4 square. Then write down here and divide it, and divided by a common table, you will get the answer immediately as 9 by 4. The option lies in option C. You can just practice by taking one more sum. Instead of 1 is to 25, you can go for 1 is to 36 and find the ratio of intensity at the maxima and minima in the interference pattern. So remember, don't use any square root, just use these numbers. So first step is we have to divide the ratios by taking root. You will get 1 by 5. Then add these two numbers. We get 5 plus 1, square that number, divided by subtract the number. We get 4 square, divide it, we get 9 by 4 as an answer, which lies in option C, which is very, very important. So now let us move on to sum number 4. Let us move on to sum number 4, which is expected and very important question 2. So let us go for the question number 4. See, question number 4 is a very, very important sum. So just let me write the question. A person can see clearly objects only between 50 centimeter and 40 centimeter from his eyes. From his eyes. In order to increase the maximum distance of distinct vision, to infinity, the type and power of the correcting lens. The person has to use, the person has to use will be dash. See, the option A is convex. The answer given is plus 2.25 diopter. Option B is concave, minus 0.25 diopter. Option C is concave, minus 0.2 diopter. And finally, option D is convex. It is plus 0.15 diopter. So, actually we have to use the formula for this particular question, but we are avoiding the formula method and we are going to do in a single step. See the two numbers, they lie between 50 and 400. 400, it is not 40, it is 400. So, this question has been asked in 2016, in which it may be repeated for the coming year in 2021. So, now what you have to do is take this maximum number 400. 400. Write down the 400 value. Before writing the 400 centimeter, convert into meter. See, 400, if you want to convert into meter, you have to divide by 100, you get 4 meter. Right? This is the first step. We are going for shortcut method. We are not using formula method, shortcut method. First, you have to convert into meter. Then, to find what is the question asked. So, he is asking to find the person will be having whether concave or convex. So, let us go with the reciprocal of this. Take the reciprocal of this 1 by 4. If you take a reciprocal, we get 1 by 4, in which we can divide like this. So, you know how to divide it. So, it go for 2 times 8, 2, 0. So, we get 0.25. So, 0.25 diopter I can write here. Just see option where it lies. 0.25 where it lies. It lies in option B. It is minus 0.25 because we are using concave lens for seeing the objects. The question has been clearly given. It is, they lie between 50 and 400 centimeter from his eyes. So, by just with the help of the answer what we are getting, we can easily click the second option as concave as minus 0.25D, because there is no where 0.25 lies. If you see the first option, it is 2.25, it is 0.2, it is 0.5. So, 0.25 lies in option B. With the help of the shortcut method, we can get the answer immediately by taking the reciprocal of the given maximum number. So, what is the maximum number here? Maximum number is 400. Take the reciprocal and divide it, we get 0.25 diopter. So, let us go with one more sum number 5 of today's session. The same lesson, ray optics and wave optics, which is very, very important. So, let us go for the next one, a linear aperture. A linear aperture whose width is 0.02 centimeter is placed immediately in front of a lens of focal length 60 centimeter. The aperture is illuminated. Normally by a parallel beam of wavelength 5 into 10 power minus 5 centimeter. The distance of the first dark band of the diffraction pattern from the center of the screen, center of the screen is option A is 0.10 centimeter, option B is 0.25 centimeter, option C 0.20 centimeter, option D 0.15 centimeter. This question has been asked in NEET 2016. NEET 2016. Okay. So now this question we are going to do with the help of a formula, because I wrote so many formulas. So write down the solution for this question. The solution has been very clearly, to get the solution we are going to use the formula finding the position of the first minima. Write down position of the first minima. Already this formula has been given. First minima on the diffraction pattern is y is equal to lambda capital D by small a. This is the formula. Already we have written. See, from the given question, small a has been given as it is 0.02 centimeter. If you study the question, you can able to find aperture. The first line 0.02 centimeter. You can just convert this one into meter. If you convert this one into meter, we get 2 into 10 power minus 4 meter. Then the value of capital D has been given. If you see the question, it has been given as 60 centimeter. See there, it has been given very clearly as 60 centimeter. See here, focal length. So now capital D is taken as a focal length, which is nothing but 60 into 10 power minus 2, in which I can write 6 into 10 power minus 1 meter. And lambda value has also been given in the question. Lambda value is given as 5 into 10 power minus 7 meter. And the question asked is to find the y pattern, that is y is equal to, we know the formula, lambda a by a, lambda d by a, which is equal to 0. I can write as 6 into 10 power minus 1 into capital D we have written, and lambda value is 5 into 10 power minus 7 divided by a value has been very clearly given 2 into 10 power minus 4. We can simplify this 3 times, and if you multiply and simplify this, our final answer we get as 15 into 10 power minus 4 meter. If you want to convert into centimeter, I can write 15 into 10 power minus 2 centimeter, which is equal to 0.15 centimeter. Just see where that option lies. The option lies in option D, 0.15 centimeter. So this is very, very important. So let us go for sum number 6 in this chapter. Sum number 6. So already we did 5 sums, 4 sums we did in shortcut method, and one sum we did in formula method. And we are going for another shortcut method. So it is question number 6. So take down this question. Question number 6. A ray of light is incident on a 60-degree prism at the minimum deviation position. At the minimum deviation position, the angle of refraction the angle of refraction at the first phase, that is incident phase of the prism, is dash. Option A, it is 0. Option B, 30 degree. Option C, 45 degree. Option D is 60 degree. It's a very important one, and there is no need for any formula to find the answer for this question. See, just see what is the incident angle. He has given very clearly as 60 degree, and is asking angle of refraction at the first phase. So let me go for solution without using any formula and any concept to find the angle of refraction at the first phase. See the answer, angle of refraction at the first phase. Angle of refraction at the first phase. If they are asking at the first phase and the condition has been given as minimum deviation, this is very important. If they are giving minimum deviation, whatever the number let them give, you divide always 60 degree by 2. You will get the answer as 30 degree. Just see where is the option. It is B, 30 degree. What is this shortcut method? If they are giving incident angle, just divide by 2. You will get the answer immediately. If it is 90 degree, what will be your answer? If it is 90 degree. If it is 90 degree, then definitely your answer will be 45 degree. Got it? If it is 40 degree, what will be your answer? Yes, you are right. It is 20 degree. So just by dividing by 2, we get the answer immediately for the question number 6, which is very, very important. So wave optics and ray optics takes the major weightage in NEET 2021, not only in 21, in all the years, this particular 2 lessons took major part in the NEET examination. So now let us go for question number 7 in the same lesson. So we are going to discuss some 10 important questions in this particular lesson. So let us go for the next one. So before going into that, yeah, this is a question. A thin prism having refracting angle (10 degree) is made of glass of refractive index 1.42. This prism is combined with another thin prism of glass of refractive index 1.7. This combination produces dispersion without deviation. The refracting angle of second prism should be option A, it is 6 degree, option B, it is 8 degree, option C, it is 10 degree, option D is 4 degree. See the question asked is refracting angle of the second prism. Remember this. So now what are the parameters, what are the values they are given? So the refractive angle of the second prism I can take as, let us go for the solution. So the refractive angle of the second prism, let us take as A dash. Now use my shortcut. See, what is the first value they are given? 1.42, right? 1.42. You always subtract 1.42. You put a number like this, -1. This is the first step. And similarly, divided by what is the next one? What is the point value as given? 1.7, right? You just similarly do in the same method. 1.7 minus 1. This minus 1 is my cheat code. So the refractive index of the first value will be subtracted 1.42 minus 1 in this model like this, and also the second one, we are going to second refractive index, we are going to subtract by 1.7 minus 1, then multiply with the new number which is given as refractive angle. See here, refraction angle by 10. So if we simplify this, we get 0.42 divided by 0.7 into 10. Correct? Then if you can simplify this, you can strike it off like this, that is 4.2 into 10 by 7 I can write. I can divide it by 0.6. So our answer will be 6 degree. The option lies in option A. You got it? First, you have to see the two refractive index. So the formula for a shortcut formula is, see here, refractive index mu1 minus 1 by mu2 minus 1 into refracting angle. This is my formula, shortcut formula. You can use this shortcut formula for this sum. A dash is equal to mu1 minus 1 by mu2 minus 1 into refracting angle. Use this formula, you will get the answer immediately for the question. Now let us go for the next sum number 8 of the same lesson. I am giving so much importance for this lesson because the weightage is more for the NEET. So in YDSC experiment, see this, in YDSC experiment, the fringe width is found to be 0.4 mm if the whole apparatus is immersed in water of refractive index four by 3 without disturbing the geometrical arrangement the new fringe will be width will be dash. Option A is 0.30 mm, option B is 0.40 mm, option C is 0.53 mm, and option D is 450 microns. This is also an important question. Let us go for the solution for this question. See, he is asking new fringe width. So let us see what are the things he has given. The fringe width solution, he has given beta is equal to 0.4 mm. Write on this, Then he has given the refractive index. Refractive index is given as mu. What is the value of mu he has given? Mu is equal to 4 by 3. And the question asked is new fringe width. New fringe width is given by beta dash is a question mark. Already I have given the formula. The formula for beta dash to find the new fringe width is beta by mu. That is equal to 0.4 by 4 by 3. Then it is nothing but 1.2 by 4, which will give you 0.3 mm. Where that option lies? The option lies in A, 0.30 mm. It's a very, very important sum. So you can take down one more sum for the practice. So instead of 0.4, you can take it as 0.32 and same 4 by 3 and comment the answer in the channel. So the last option is, it is 0.24 mm. The next one is 2.4 mm. You can take this one. And let us go for sum number 9. Let us go for sum number 9 in the same lesson. So the question is, take to the question. In YDSC experiment, see I am giving importance for YDSC, definitely one question will come. In YDSC experiment, two coherent sources are placed 0.9 mm apart and fringe are observed 1 meter away. 1 meter away. If it produces central fringe, the wavelength of monochromatic light is used would be the another important question expected this year 2021. The option A is, it is 60 into 10 power minus 4 centimeter. Option B is 10 into 10 power minus 4 centimeter. Option C is 10 into 10 power minus 5 centimeter. And option D is 6 into 10 power minus 5 centimeter. So the question, we have to see the important point here. So let us write down the given values. What are the given values here? So let us go with the solution. So again I'll read the question. In YDSC experiment, two coherent sources are placed 0.90 mm apart and the fringe are observed 1 meter away. If it produces central fringe, not central fringe, it produces second dark fringe. If it produces second dark fringe, at a distance of 1 mm, write down this, I left some point, at a distance of 1 mm, from the central fringe, the wavelength of the monochromatic light is used would be, this is the question. So he has given dark fringe. See in the question, the hint is he has given us dark fringe. So that too in YDSC experiment, dark fringe in YDSC experiment. So you know very well what is the formula for dark fringe wavelength. So conditions for dark fringe, already I given a formula, xd by d is equal to 2n minus 1 into lambda by 2. This is the condition for dark fringe in YDX experiment. Please note down this formula again. It's very, very important. From this, we can also find the value of lambda. So lambda is 2xd divided by 2n minus 1 into capital D. The value of x has been given. The value of x is given as 2 mm, which the question, you can see the question, the value of x has been given, central fringe 2 mm. Then you can write as 2 mm, which is equal to 2 into 10 power minus 3 meter. And the value of distance d has been very clearly given, that is 0.9 mm, that is 0.9 into 10 power minus 3 meter. And n is given as 2, second dark fringe. And if you substitute here in this formula, we get lambda is equal to 2 into 10 power minus 3 into 0.9 it is not 2 mm, it is 1 mm in the question, it is 1 mm. Now in the formula, now we can substitute here. In the formula the number 2 is there, I can substitute 2 here. The value of x has been given as 1 mm, it is nothing but 10 power minus 3 into d is 0.9 into 10 power minus 3 divided by 2 into 2 minus 1. Capital D has been given as 1, capital D is given as 1 meter. So if you substitute, after simplifying we can get 2 into 0.9 into 10 power minus 6 by 2 into 2 is 4 into 3, that is 3 we get. So now after simplification, if you simplify this particular value, we get 6 into 10 power minus 5 centimeter. This will be your answer. Just check it up where that answer lies. So it is option D is the answer. Option D is the answer. And finally, with the last sum in the same lesson, we are going for the 10th question. It's a very, very important question. Very important question. Write down, if the polarizing angle is 60 degree, find the refractive index. A simple question. If the polarizing angle is 60 degree, find the refractive index. So this is the question. Option A, B, C, D will be given. So it is 1 by root 3, 1 by root 2, 1 root 3. So these are the 4 options it will be given in the question. See, this comes under Brewster's law. Let us go for the solution. The formula for refractive index according to Brewster's law is mu is equal to tan IP. That implies mu will be equal to tan 60 degree. IP is 60. The given value of polarizing angle is 60 degree. You know very well what is the value of tan 60. Tan 60 is root 3. Then your answer lies in option D. So this is another one of the important one. The same questions sometimes they may ask like this also. If the refractive index, is 1, find the polarizing angle. Find the polarizing angle. Option A 60 degree, option B 45 degree, option C 90 degree, option D none. Another one. So let us go for the solution. The value of mu has been given, and the question asks is to find the value of IP is a question mark. According to Brewster's law, we know the formula mu is equal to tan IP. What is the value of mu? It is 1 is equal to tan IP. That implies IP will be equal to tan inverse 1. The value of tan inverse 1 is nothing but 45 degree. So our option lies in B, which is so important. So apart from these 11 questions, I have already given a live session last year in the same channel. You can able to see bandwidth derivation. All the subscribers and viewers, I am telling this, please go through my live session video bandwidth, in which I have given some 5 NEET questions. Last year one question came from this. I am very proud to say last year out of these 5 questions, one question came into the NEET 2020. So go through bandwidth and also Brewster's law equation. Brewster's law in my live session. Now we are going for the last another 15 minutes because we have to finish off the alternating current and electromagnetic induction. So wave optics and ray optics is over. Now we are going for EMI, electromagnetic induction, and AC, alternating current. So formulas to be noted. So this particular 2 lessons has been taught to our academy also recently. So in which I have given so many formulas also related to this. So however, let us write the formulas, important formulas in this lesson. Important formulas expected to come for NEET 2021. So first formula is flux, magnetic flux. Pi is equal to B vector BA cos theta. You can write out this first formula. The second formula is same magnetic flux. Pi is equal to Li. L is called coefficient of self-inductance. Next, formula number 3. In LCR circuit, impedance Z is equal to root of R square plus XL minus XC the whole square. R is called resistance and XL is called inductive reactance. And XC is called capacitive reactance. Next, let us go for question number formula number 4. So pi in LCR circuit, pi is equal to tan inverse XL minus XC by R. Next, formula number 5. Magnetic field at the center of the solenoid. Magnetic field at the center of the solenoid. B is equal to mu naught Ni. N is called number of turns. Mu naught value you know very well. Mu naught value it is 4 pi into 10 power minus 7. Remember. The next formula number 6. Input power in a transformer. You know very well in a transformer sum definitely it will come for the coming NEET 2021. So in a transformer, the formula for input power P in is equal to VI is the general formula. I can write as VP IP. VP is called voltage in the primary coil. IP is called current in the primary coil. And Pn is the input power in the primary coil. So this is called input power. This is called voltage in the primary coil. voltage in primary coil, and IP is called current in the primary coil. Current in PC I can write primary coil shortly. And formula number 7. Similarly, same in transformer. In transformer, P out will be equal to Vs into Is. Vs into Is. If you want Is from this, I can also write output power divided by Vs. Please note down this. And formula number 8, efficiency of a transformer. Efficiency of a transformer. Efficiency of a transformer. Efficiency of a transformer is eta is equal to P out by P in. Output power by input power. Again, that implies eta is equal to, you can write this formula. Output power formula is Vs Is divided by Vp Ip. Note down this. If you want Vs from this, we can also write as eta into Vp Ip divided by Vs into Is. Not Vs, just Is. Eta into Vp into If by Is. See, it's very important formula. Please note it down because we are having one question in which I am expecting this year based on this formula. And also, again, in a transformer, we are having one more formula, that is formula number 9. Formula number 9. Formula number 9 is Vs by Vp is equal to Ns by Np. This is also a condition in a transformer. And for the formula for power, power is generally is given by P is equal to Vi. We can also write the formula as V square by R. So remember these two important formulas. Based on this also, I am expecting one sum this year. And this is also an important one. And resonance frequency. Write on this resonance frequency. Resonance frequency. Nu is equal to 1 by 2 pi root of Lc. Please note down this formula. Nu is equal to 1 by 2 pi root of Lc. And formula number 12, XL is equal to L omega is one of the formula. XC is equal to 1 by C omega is formula. L is called inductive reactance, L is called coefficient of inductance. Coefficient of inductance. And XL is called inductive reactance. And Xc is called capacitive reactance. So, these 12 formulas you have to note it down, and finally with 13th one, power factor, very very important one. Power factor. Power factor is given by the formula cos pi is equal to R by Z. Please note down this formula. Power factor cos pi is equal to R by Z. The same cos pi is equal to, we can also write cos pi as VR by root of V square R V square R plus VL minus VC the whole square. So, these are the 14 important formulas you have to note it down in alternating current and electromagnetic induction. These 14 formulas. 100% I will give you assurance, 21 year, all the questions will be framed only on the basis of these 14 questions. Take it granted. So, now we are going to discuss some few questions. Within 10 minutes the class will get over. Only 3 to 4 sums we are going to discuss in this lesson, which is very very easy too. So let us go for the first question in this lesson. Question number 1, in electromagnetic induction and alternating current, which is very easy too. So a question will arise from transformer this year. 100% chances are there. 100% chances are there. Questions will arise from transformer. Remember, transformer part is so important. So let us go with the first question in a transformer. A 220 voltage. A 220 volt input is supplied. Input is supplied to a transformer. To a transformer, the output circuit draws a current of 2 ampere at 440 volts. If the efficiency of the transformer is 80%, the current drawn by the primary and primary windings of the transformer is option A, it is 3.6 ampere, option B is 2.8 ampere, option C 2.5 ampere, option D it is 5 ampere. Very important question. So important one. So let us write what are the given. See solution. Let us go for the solution. Input voltage has been given. So I can write as Vp. It is 220 voltage. See here. Input voltage 220. Then write on the other given values too. So the value of output voltage is given, which is given by Vs. Vs is given as 440 voltage. See here, 440. Then he has given Is too. Is value is given as 2 ampere. Draws a current. Draws means is Is, secondary coil current. So the question asked is to find the value of Ip. Ip is a question mark. And eta has been given, it is 80%, 80 by 100 has been given. So these are all the given values. So Vp, Vs, Is and eta has been given. Now we have to find the value of eta with the help of a formula. Eta is equal to Vs, Is by Vp, Ip. Now from this find the value of Ip. If you want Ip, it is Vs, Is divided by Vp into eta. Now substitute the values. Ip is equal to what is the value of Vs? If you see the Vs value, it is 440 into 2 divided by Vp is how much? Vp is 220 and eta is 80 by 100. This 100 will go to the top. 440 into 2 into 100 divided by 220 into 80. If you simplify this, you will get the answer as 5 ampere. So just see where is it option lies. The option lies in option D. Option D. Yeah, we have finished the first question. So let us go for the second question. We'll rush it up. So transformer sum is very important, in which you have to note it down. So let us go for the another important question now. This question is also has been asked in 2013. A current of a current of 2.5 ampere flows through a coil of inductance 5 Henry. The magnetic flux linked with the coil is option A 0.5 Weber, option B it is 12.5 Weber, option C 0, option D 2 Weber. So this question is also so important. Please note it down. So let us go for the values which you have given. Solution, let us go for the solution. The value of L has been given as 5 Henry and the value of I has been given as 2.5 ampere. And the question asked is magnetic flux. Magnetic flux is a question mark. You know the formula for magnetic flux. Pi is equal to Li is the formula. What is L? What is I? L is 5 into 2.5. So if you multiply, we get 12.5 Weber. Just see where the option lies. The option lies in option B, 12.5 ampere, which is very, very important. Let us go for question number 3, which is very, very important, expected 21. So this is also an important question. A coil of resistance 400 ohms is placed in a magnetic field if the magnetic flux pi, which is given in Weber, linked with the coil varies with time t second as pi is equal to 50 t square plus 4. The current in the coil at t is equal to 2 second is option A is 0.5 ampere, option B is 0.1 ampere, option C is 2 ampere, option D is 1 ampere. This question has been asked in NEET 2012. I am expecting a model in this question because this particular question involves a differentiation we should know. Without knowing the differentiation, we cannot do this sum. So let us go for the solution in the same question what I have given. So the question has been given as pi is equal to 50 t square by 4. Just go with the differentiation. You know how to differentiate it. D pi by dt is, you take these two down, we get 100t. The value of d pi by dt at t is equal to 2 seconds, he has given here very clearly. At t is equal to 2 seconds, 100 into 2. So 100 into 2 is how much? It is 200. But the question asked is to find the value of, we got the value of the value of I is asked. The question asked is to find the value of I. Okay, let me write the formula for I. The value for I is equal to, we can write as E by R. The value of E is also can be written as minus d pi by dt into R. The value of minus d pi by dt has been given here. See here, this is the value of d pi by dt. It is minus 200. The value of R is already given in the question. See the value of R here. The resistance 4 ohms. So I can write as 400. Strike this one and you will get minus 1 by 2, in which I can take down as positive value, which is equal to 0.5 ampere. The value of I is 0.5 ampere, which lies in option A, which is also very, very important. So important sum, it's a very important sum, and we are going for the last and final sum of today's session, last final sum. So let us go for this model. A long solenoid, the last question. We already finished 3 important questions in this model. The question number 4, a long solenoid as 1000 turns, when a current of 4 ampere flows through it, the magnetic flux flows through it. The magnetic flux linked with each turn of the solenoid is 4 into 10 power minus 3 Weber. The self inductance of the solenoid is option A, it is 2 Henry, option B 1 Henry, option C 4 Henry, and option D it is 3 Henry. So let us go for the solution now. The last and final question, let us go for the solution. See, as very clearly given in the question, number of turns has been given, n is equal to 1000 turns. And the value of I, current, has been given, it is 4 ampere. See here. And also the value of pi has been given. Pi is nothing but 4 into 10 power minus 3 Weber. And the question asked is to find the value of L. This is the question. Self-inductance he has asked. See here clearly. Now, let us go with the first formula. The formula for total flux. Let us find the value of total flux first. To find the total flux, the formula is pi is equal to n into pi naught. So this is pi naught. So what is n? It is 1000 into 4 into 10 power minus 3. So if you simplify, we get just 4 Weber. We got the value of total flux. And we know pi is equal to Li is the formula. Now we required L. So pi by I. The value of pi is 4. The value of I is also 4. So if we cancel it, we get 1 Henry. So the option lies in A. So B. The answer lies in option B, it is 1 Henry. So totally we have finished 14 questions, which is very important for the coming NEET expected 20. And in alternating current electromagnetic induction, in our channel, we have put already so many questions. So adding together, so totally it covers around some 20 important expected 21 questions. So thank you very much for being with me for finishing out these 14 questions, which will come for the NEET 2021. And again, let us meet for one more session very shortly. Thank you very much and bye-bye. See you. Let us meet for the another session very soon.